All right, so let's get another one of these distance learning lessons done. This will be the last one of the chapter, so we'll have a test coming up here with the review. But a little review for now. So far we've learned two ways to solve a system using matrices. So the first way we learned was Cramer's rule. So that's when you take your matrix here. So we have 3, 1, 3, -2. What we do is we find the determinant of that. So to find the determinant, we took -6, so multiplying these two, minus what you get when you multiply these two. So -6 minus 3, we get a determinant of -9. Okay? Then what we do is for x, we replace our x's with the constants, 15 and 6. And then we leave these two alone. And find the determinant there. So here we have -30 minus 6. So that's -36, which then we divide by that -9. So x equals 4. And then for y, we leave the x's alone, put 3 and 3, we replace the y's. So now we replace the y's with 15 and 6. Find the determinant again. So it looks like we have 18 minus 45, which I think is -27. And then over -9. So we get 3 for y. So the answer is 4, 3. We already know what it is, but let's just review how to do it by multiplying inverses. So when you're using the inverse, okay, first of all, we're going to take the inverse of the 3, 1, 3, -2. So first we find that determinant, which we already knew is -9. So 1 over -9. And then we got to multiply that. Oops, I should have wrote it down here. 1 over -9, come on, times, okay, so if you remember, we switch these two around, so -2 and 3, and then these becomes negative, so -3, -1, so I can't talk, -1/9 of those, so that would give us 2/9. -1/9 times -1 is +1/9. And then times -3, so 3/9. And 1 over -9 times 3, so -3 over 9. And then we take that times this matrix here, the 15 and the 6. So that's going to give us a 2 by 2. Make it really big so we can see what's happening here. So to get row 1, column 1, take row 1 times column 1. So 2/9 times 15 is 30/9, and then plus 1/9 times 6, so 6/9. And then to get the bottom, we take this row times that only column there. So 3/9 times 15, 45/9. And then -3/9 times 6, which is -18/9. So this becomes 36 divided by 9, which is 4. And then this becomes -27 divided by -9, which is 3. So those are the two ways we've learned, and we're going to learn one more way using matrices. So first we're going to talk about an augmented matrix. That's just when you take one of these systems, make it a matrix, kind of like coefficient matrix on the left here, and then you separate your constants with a dotted line, so 15 and 6. So this right here is an augmented matrix, and you just want to make sure everything's in standard form. So x then y equals the constant. So there's 3 different things you're going to be able to do to an augmented matrix. Okay, the goal is going to be to get the matrix into reduced row echelon form. which we'll talk about a little bit more on the next page. Um, that's going to be the goal. What we can do is one thing we can do is we can switch rows. So we can just take row 1 and row 2 and just flip flop them. So that's what's happening here. You can multiply a row by a non-zero constant. So you can multiply a row by any number you want other than 0. Okay. And then finally, you can replace a row with a sum or difference of that row in another row. So in this example, we're taking our row 2 and we're subtracting row 1 from it. So 3 minus 3 is 0. Negative 2 minus 1 is negative 3. 6 minus 15 is negative 9. So it's another thing you can do. You can add and subtract rows. I will say on the delta assignment, it only allows you to add, which is a little annoying, but what you can do then with that is you'll just have to multiply by a negative to one of your rows, and that's not a huge deal. All right, so here's kind of what it looks like. So when we say row or reduced row echelon forms, sounds like a really fancy thing, but all it is it's the form where on the left you have the identity matrix, right? So you got ones down the diagonal and 0, 0. The reason that's important is, well, if we put this back as an equation, this would just say x equals 4. This would say y equals 3. So when we get it down to here, these two are going to be our answers. So the goal is to get ones here and zeros here. Okay. So on this one, okay, here's our system. So 3, 3, 1, negative 2. It's the one we did earlier, right? And then 15 and 6. So the first thing that I did is, well, and I'll just tell you this now, is you want to get the zeros first. Don't worry about getting ones right away. You got to get the zeros first or it just takes forever. So get your zeros first, is what I'm saying. Now I want a 0 to be in this spot in order to get to here, right? So I notice these numbers are the same. So what I can do is I can take row 2 and subtract row 1. Now I have to do that for everything in row 2 and row 1. So I take 3 minus 3, which is 0. Negative 2 minus 1, negative 3. 6 minus 15 is negative 9. So I got one of my zeros here, so that's nice. The other 0 I want is up here. Well, right now, these aren't matching. So what I want to do is take row 1 times 3. That'll get these two to match up. So 3 times 3 is 9. 1 times 3 is 3. 15 times 3 is 45. So now I have these two matching. So, and on the delta assignment, again, it said it's only to let you add. So you want one negative and one positive, right? Because when you add them, they make 0. So here, I want to get the 0 here. So I take this row, and I'm going to add the row 2 to it. So 9 plus 0 is still 9. Oh, my pen's shorting out on me. So 9 plus 0 is 9. 3 plus negative 3 is 0. 45 plus negative 9 is 36. Now, since I got my zeros, once you get the two zeros, you just got to multiply the rows by what you need to get 1. So what do I multiply to 9 to get 1? Well, you just multiply it by its reciprocal, right? So multiply it by 1/9. Okay, that'll get you 1, and then 1/9 of 36 is 4. Here, well, negative 3. So reciprocal of that, negative 1/3. When I multiply everything out, I get 0, 1, and 3. So 4 and 3 are my solutions. All right, so a couple more examples. First, make sure they're in standard form. Okay, they are, so that's a plus. We're going to write our augmented matrix. So 2, 1, 3, negative 2, and then 11 and 6. I don't know why I put a fraction bar there. You don't need that fraction bar. Okay, so again, you want the zeros first. Right now, nothing matches, but I see in this one, I just got to multiply it by 2, and then I'll be able to cancel these out right away. So I'm going to do 2 times row 1. So that's going to give me 4, 2, 22. Okay, now I want to get a 0 up here, so I'm going to take my row 1 and add row 2. So 4 plus 3 is 7. And then 2 plus negative 2 is 0. 22 plus 6 is 28. So that's looking better now. 3, negative 2, and 6. So now you're probably wondering, how in the heck am I going to make this cancel out with the 7? Well, you want to think of a term that they both fit into, right? So one number you know they both fit into, take 7 times 3, that's 21, right? So essentially, we're going to take 3 times row 1 and 7 times row 2, because then we'll have 21 and 21. Fortunately, the delta, you can only do one of these at a time, but it's not a huge deal. I'm only giving you a few problems to do. So let's multiply those out. So I'll put the next one up here. So that would give me 21, 0. Let's see, 28 times 3, 56, 76, 84. And then times by 3 on the bottom, so 21, negative 6, and, oh sorry, times 7, what am I thinking? Let's fix that. 7 times negative 2 is negative 14. Come on. That's a negative 14 if you're wondering. And then take 7 times 6, and that's 42. So now, since I want my 0 here, I'm going to take row 2 minus row 1. Again, on delta, you're going to have to change one of these to a negative, so you might multiply by like a negative 7 here, right? So let's go ahead and do that. So row 2, so row 1 stays the same. Okay, row 2 minus row 1, so 0. Negative 14 minus 0 is still negative 14. 42 minus 84 is negative 42. And now it's multiplied by reciprocal time, right? So I'm going to take row 1 times 1 over 21. Essentially, we're dividing by 21. Row 2 times 1 over negative 14. Sorry, my writing's really crappy today. I'm trying to fit it all in here. So then what I get is 1, 0, 0, 1. So 1 over 21 times 84 gets me 4. And negative 14, or sorry, negative 1/14 times negative 42 is going to be 3. So my solution is 4, 3. Okay, then we can check our answers, right? So that would be 8 plus 3 is 11. Good. 3 times 4 is 12. This would be minus 6. That equals 6. So right on. We got it. All right. Next problem. Not actually going to have time for, because it only gives me so much time to fix. Or to not to fix, to do the video. So I'm just going to go ahead and give you the assignment. It's Delta Math. So make sure you log on to Delta Math, get everything done, okay? Even if you get it wrong, it lets you, go back and try again. So keep working, get it up, get all 100% done. If you're getting stuck, you need help, shoot me an email. If you want to see another example, I'll go ahead and make another video, and I'll throw it on YouTube if you want to check it out, and I'll put it on the Canvas as well. So that's part 1, which it's not really part 1 and part 2. It's question 1 and question 2. Question 2 will be on a different video.